Section 7.2, adding and subtracting rational expressions. I did an example just a second ago that was multiplying and dividing versus adding and subtracting using the same numbers. I'm just going to talk through that real quick. 2/5 times 1/8 and 2/5 plus 1/8. Here we just reduce on the top here and multiply the tops together and the bottoms together and 1/20. But here, this is going to be the process that we're using today. This is why this is a little bit harder. Adding and subtracting is harder than multiply divide. 2/5 plus 1/8, we find a common denominator of 5 and 8, which is 40. And then we look at the 5 and we say, what do we take times 5 to get 40? And that's 8. Take 2 times 8 also, and that's 16. Same thing over here. We're going to multiply by 5. And then all you do is add the 16 and the 5. But what happens to the bottom? It stays 40. It does not become 80. So keep that in mind. You do not change that to 80. So 21/40, and that is all. Okay? So that same process, but now we're going to be doing like X's and such. Okay? So the main thing that we're going to focus on today, because we're taking 2 sections to do this, okay, or 2 days to do this section, okay, the thing that we're going to be focusing on today is finding the common denominator, or they call it an LCM. What does that stand for? Least common multiple. Okay, now let me talk about what least common multiple is. Okay, these two, when we're adding them together, my denominators are 6 and 9. Okay,
That's crazy.
so 6 and 9. I could use 54 as my denominator, right? 6 times 9 is 54. But is that the smallest number? Is that the least number that both of them go into? Jason's saying 18 is what you can use. So instead of using 54, we use 18 instead. Does 6 go into 18?
Yes.
Okay.
Yes. Does 9 go into 18?
Yeah.
Yes. So rather than using 54, we want to use 18 instead, because that is the lowest or the least common multiple. Okay? Now, doing this like we did up above, what do you take times 6 to get 18? 3. So we have to take 5 times 3 also. So this is going to be 15. Okay? What do we take times 9 to get 18? 2. So we take 4 times 2, which is 8. And we're adding these together. So 15 over 18 and 8 over 18. 23 over 18. And that's what he will look like. Yeah? Okay? They have that down here. So 18 is the number that we're going to use. Okay. 23 over 18. Yeah? Okay, now we're going to be doing stuff that looks like this. Okay? And we're trying to find a least common multiple of these guys. Okay? Least common multiple of those guys. All right? So think about what that entails. We're going to end up breaking each one of these down. Okay? And breaking each one of those down. What?
When are we going to use this one?
Just wait. Just wait. Okay? All right. Let's go down and let's switch to this example so we can get our feet just wet a little bit. I'm going to go to example 1, okay? Now, we have 3 things that we're trying to find the least common multiple of instead of just 2, okay? Here is 3 things. Ready? Are these guys trapped or not trapped? Because the same kind of concept applies. Trapped or not trapped?
Not trapped.
These are not trapped, okay? Not trapped. Write that down. Not trapped. So each one of these 3 pieces, we don't have to try to break him down like he's a trinomial or anything like that. We just look at the pieces, okay? So we're trying to find a least common multiple of those 3 things. So start with the numbers, 6, 15, and 9. And we want one number that all 3 of them go into. Not that what goes into those, but what all 3 of them go into.
Well, that's BS.
Okay? So if you don't know, here's where you start. Which number is the biggest number? 15. So I always start with the biggest number and I say 15. Does 9 and 6 go into 15? No. What's the next number up from 15? 30. Does 9 and 6 go into 30?
No.
6 does. 9 doesn't. Okay? Let's go to 45. Does 6 go into 45? No. Does 9?
No.
9 does, but 6 doesn't. Okay, so we have to go to 60.
Yes.
Does 6 go into 60?
Yes.
Yes. Does 9?
No.
No. So we got to go to 75.
Gosh darn it.
Okay? We go up by the 15s because 15 is the largest one to do, right?
No.
So, does 6 go into 75?
No.
Get your calculator out. Does 6 go into 75 evenly?
No.
75 divided by 6, is it even? No. Does 9 go into 75?
It'd be 12
No. So the next one up from there is
What?
No, it has to be by 15. See?
It has to be by 15. 75 plus 15 is 90. Does 6 go into 90?
Yes.
Does 9 go into 90?
Yes.
We found our number. Okay, so 90 is going to be the number that I use. So cross off the 6, the 15, and the 9. We're done with the 9s. Or we're done with those numbers. Okay? Now, some people think that doing the variables is a lot easier. Okay? How many x's do I have to have in order for each one of these to fit into it?
1. 2.
I have to have 2. Okay, let me show you.
2.
Does x squared, or does x go into x squared?
Oh, yeah.
Does x squared go into x squared?
Yeah.
Does x go into x squared?
Yeah.
Right?
So,
Now, all at the same time, we don't have to fit them all in there at the same time, right? That would be 4 of them. But each individual one, we have to fit them in there. So what's the rule for exponents? You just take the biggest one, right? So y's, I need y's. This one, does y go into, what exponent do we need to have on y's? How many y's do I need to have?
4.
4. Does y go into y to the 4th?
Yep.
This one doesn't even have a y, so we don't have to worry about it. Does this y to the 4th go into y to the 4th?
Yeah.
Yes. So the rule for exponents is you just take the highest one. Yeah? Yes? Good? Okay? All right. I'm going to give you one over here, and I'm going to have you do this one by yourself. Okay? So off to the side over here, let's give another example just so that you can be clear on this. Okay? Let's say 2x to the 3rd, y to the 2nd, and I'm going to do a z. And let's say I have
There's another problem underneath that.
6, and let's do 5. X, y to the 7th, z to the 4th, and x to the 5th, y, z to the 9th power. Okay? I want to find the least common multiple of those 3. Okay? You do it. You try it. Try it on your own, and then we'll see what we get. The least common multiple. So start with the numbers, and then figure out what the variables need to be. Okay? So start with the numbers. 2, 6, and 5. What number do we have to use? You want the lowest number. The lowest number. The lowest number that all of them go into. And then do your variables.
Can I go to the bathroom?
Just wait.
I don't know.
We'll just wait.
I'm one out.
Did you get it figured out?
I thought you said this was harder.
Okay.
It's like wait.
It is, well, this part's the easy part. Okay. What's your number? What number does 2, 6, and 5 go into?
600.
30. We want the lowest number that all of them go into, right? The lowest number is 30, okay? Now, how many x's do you have to have?
5.
5 in order for all of them to fit in there, right? You have to have 5 x's. How many y's do you have to have? 7 in order to have all of them fit in there. How many z's? 9. This is your least common multiple. So if I was trying to find a common denominator of these guys, this would be it, right? Okay? Good?
Can I go to the bathroom now?
Now, one more thing.
Getting the word.
This is where we're going to get to next. All right, you ready? I'm in a different color. I'm going to put these in here. If this was my common denominator, watch this. If this was my common denominator, what would you have to multiply the 2x to the 3rd y squared z by to get to that?
15.
I would have to multiply the 2 by 15, okay? How many x's would I have to multiply by?
X squared.
X squared, how many y's would you have to have?
Y fifth.
5 more, how many z's would you have to have?
1.
8.
8 more. Do you see that?
What? Oh.
Okay. Now let's go down to the 6. What would you have to multiply 6 by to get 30? 5. How many more x's would you need?
4.
4. Chase, how many more y's would you need?
Couple. 5.
We're on this one.
7. None.
None. How many z's do you need?
5.
5. Okay. Now if we're starting with 5, how do you get from 5 to 30? You would have to multiply by 6. How many more x's would you need?
None.
None. How many more y's would you need?
6.
How many more z's would you need?
None.
None. So I can get rid of him. Okay? Do you see this? Do you see how this works? So we're only trying to find the least common multiple at this point, but be thinking that, like, the next step will be, what do I have to take each one of those times, like we did up here with the 6 and the 9. What did I take times 6 to get 18? I have to take that times 5 also. What do I have to take times 9 to get 18? I have to take that times 4 also. So be looking for what you need to take times it to get to the least common multiple. Okay? Good? All right, now, those were not trapped. That was the easy part. Now the hard part.
Jake, why
Are you ready? Now the hard part, okay? These are trapped. No, just wait.
I drank a lot.
These guys are trapped. Okay? So, when we have things that are trapped, we're going to break down first. And the three things that we have, the three methods that we have to break down are simple trinomial, right? What's another way that we can break stuff down?
I don't know.
Greatest common factor.
Complex trinomial, I'm not going to give you any of those.
Greatest common factor.
Greatest common factor, so we can pull something out, right? Or a difference of squares. So be looking for those three things when you're looking for trapped stuff.
Why do you have a can
Okay.
of beans?
Shh, just wait.
Do you eat plain?
So we can
Shush.
get
Is that your lunch?
This guy's a simple trinomial. Let's break him down. So, we're looking to multiply to get 40. But when you add them, give you 3.
We should count.
Shh. Multiply to get 40, add to get 3. What do you got? Multiply to get 40, add to get 3.
0.
No.
Oh, it's a
Multiply to get 40, add to get 3.
8, 5.
8 and 5.
-8, +5.
Negative 8, positive 5. Okay, good? Negative 8, positive 5. That's broken down. Okay, now we're going to skip over to this one. I did that one first. Let's skip over to this one. This one is a trinomial, but it's not complex. Most trinomials start with x squared and then x, and then they don't have an x on this one.
What's greatest?
So we have to pull out something first. What can you pull out?
Next way.
Let's pull out an x squared to start with. Okay, write this down, Chase.
How do you do
No, just hush.
I was asking.
Pulling an x squared out, okay? If you pull an x squared out at x to the fourth, what do you have?
X squared plus 8x plus 15.
X squared plus 8x plus 15, right? We're taking that x squared out the front, okay? Now, this that's left over is a simple trinomial, and we want to break him down, okay? So the x squared is just going to hold on for just a second, okay? What do you say? 3 and 5? Pluses, minuses, one of each. Both plus. Plus 5, plus 3. Does it matter which one you do first?
No.
No. Okay, so we have x plus 5 and an x plus 3. Here's how you do this. Ready? We've just broken them down. We haven't found the least common multiple yet. We've just broken them down. Ready? To find the least common multiple, I go through each of these pieces. There's 3 over here and there's 2 over here. And I take inventory. All right? And I write down things that I need. Okay? So going through each piece. X squared, I know that my least common multiple needs to have an x squared in it. Yes? I know that my least common multiple needs to have an x plus 5 in it. I know that my least common multiple has to have an x plus 3 in it.
X minus 8.
Okay? I know that my least common multiple has to have an x minus 8 in it. And I know my least common multiple has to have an x plus 5 in
Oh,
it.
we already have it.
But we already have it right here, so we don't need to list it twice.
X plus 10.
Does that make sense? No. You don't list it twice, okay? So you go through each of those 5 pieces and you just write down one of each, right? One of each that you need. Yes? Okay, now, this is my least common multiple. But we're going to do one better than that, and I'm going to get you guys ready for the next step. Ready for the next step? If this is my least common multiple, what does this guy not have that he needs out of there? What does he not have? He needs an x minus 8, so write that right below it. That's going to be the next step, okay? He needs an x minus 8. This guy right here, what does he not have that he will need? He needs an x squared and an x plus 3, right? Those pieces, okay? So what you're trying to do is from your least common multiple, which is just a combination of all of them together, no doubles. You're just trying to look and say, what does he need multiplied by? That's the next step. Okay? For today, all I'm going to have you guys do is just these, finding your least common multiple. Okay? Let's go
I know how
down.
to do that one.
In example 2, you what?
I think I know how to do it. Wouldn't you change the bottoms to 10x?
Yes.
To equal 10x?
Yes. Okay, so hold on. Just wait a second. We're almost done with this last example. Okay? A, we want to find our common denominator. Okay? So we're going to do part of this problem. We're going to do part of example 2. Okay? And what I want to do is I want to find a common denominator.
10.
Okay? So 2 and 5, you said the common denominator is 10. So I'm going to change both of those to 10x's, right? And how many, or to 10. How many x's do you need in your bottom? How many x's do you need?
1.
You just need an x, right? 1x. Now, does 2x go into 10x?
Yeah.
Yes. Does 5x go into 10x?
Yes.
Okay, now, going forward, what would you have to multiply by 2x to get 10x?
5.
5.
Times 5. What do you have to multiply by 5x to get 10x? 2. Okay? So, our least common multiple. What's the least common multiple here? 10x. This is the least common multiple. That's just going to be my new bottom number, right?
We have to write what it is.
Okay? We're going to finish the rest of this problem tomorrow because I'm not going to go any further than that. Okay? But your least common multiple is what you're finding today is just 10x, yeah? Okay? Now, this guy is, you've already done it? That's fine. This guy is trapped or not trapped? Not trapped. Not trapped. Okay? Now, with the trapped ones, that's what part B looks like. This guy is trapped. What strategy do we do when we're trapped? When we're trapped, we have to
So, like,
break him down.
yeah.
So, this guy is a trinomial. What do you multiply to get 3, but when you add them, give you negative 4?
-1 and -3.
X minus 1, X minus 3. That's what that is. Okay? Now, also a trinomial for this second one. Multiply to get -6, add to get positive 5. It's not 2 and 3.
Positive 6, -1.
X plus 6, X minus 1. Okay, so if you're going to do your denominator, I'm going to write these two pieces out. What do you need to have in your denominator? Look, just go through each piece by piece. I know I need X minus 1. I know I need an X minus 1. I know I need an X minus 3.
X plus 6. And that's
I know I need an X plus 6.
That's it.
And I know I need an X minus 1, but we already have one of those. So I'm going to write him on each piece. Okay? That's what he's going to look like. We're going to change those, and then let's go ahead and label out what do we need to take this guy by, or times, to get this bottom. He has an X minus 1 and he has an X minus 3. What does he need? He needs an X plus 6. So I'm going to write X plus 6 over here. Okay? This guy, what does he need in his bottom? I got, that's not what I want. I got too close here. No. What is that thing? That is an X minus 1. Okay. So what does he need? What do we need to multiply him by? X. X minus 3. He needs an X minus 3, yeah? Okay? Does that make sense? So, what's our least common multiple? What's the least common multiple? Least common multiple is the denominator that we found, right? It is X minus 1, it is X minus 3, and it is X plus 6. Okay? Good?
Mm-hmm. Can I go to
All
the
right.
bathroom?
For today, I'm going to explain your homework and then you can go. For today, for your homework, I'm going to give you this 7-2 skills practice, and all I want you to do is 1 through 6. You're finding the least common multiple. Okay? You're just trying to find the least common multiple. All right?
So we just have to do what we did.
Can I go to the
Good,
bathroom?
good. You just have to find, like what you did on example 1.
Can I go to the bathroom?
Yes, you can go to the bathroom.
All
All right.
Ask April what class my decision because I need to get my phone out of the car.
Sure.
So, what are we gonna use this for?
Where's my... There we go.
Yeah, she won't.